Hello viewers, in today's class we are going to discuss some important problems from differentiation, right? And here the derivative, that is dy over dx, and the second order derivative, which is d2y over dx2, both are involved, right? So here we'll solve four problems based on the first derivative and second derivative, right? So what we will basically do in this lecture, that is we are given a function, right? Say we are given a function, say f of x, right? And then we'll find the derivative of y with respect to x, and then we'll find the second order derivative, that is d2y over dx2, and then we'll prove some given result, right? So let us start, and let us first take the problem. So here we have the first problem, and here we are given y is equal to sine of sine x, right? And we have to show that d2y over dx2 plus tan x times dy over dx plus y times cos square x is equal to 0, right? So here we are given the function in this form, and we have to prove this statement for this function, right? So what we will do, we'll first find the first derivative. So let us find the first derivative, that is dy over dx, right? So this is d by dx of sine x, right? And see, here we have the function of a function, right? So we have sine x inside sine. So what we will do, first we'll find the derivative of sine with respect to sine x, which is cos x, that is cos of sine x, and then by chain rule we'll differentiate sine x with respect to x. So the derivative of sine x, right? So now we have cos of sine x, and here the derivative of sine x is cos x, right? So we have obtained the first derivative like this, right? So now let us find out the second derivative, right? So for a second derivative, what we will do, will differentiate both sides with respect to x. So we have here dy over dx, and here we have d by dx of cos of sine x, and then cos of x, right? So this is d2y over dx2, that is the second derivative of y with respect to x. And here see, we have two functions, right? So this is the first function and this is the second function. So we'll use the product rule for differentiation here. The product rule goes like this: if we have two functions of x, that is f and g, then what we do here, we'll take the first function, then we find the derivative of second one, then we take the second function and we find the derivative of first function, right? So here we have f as cos of sine x and g as cos of x. So we'll write first function cos of sine x, then we'll write the derivative of cos x, then plus, then we'll write cos x and the derivative of cos of sine x, right? Okay, so now we can simplify it. So here we have cos of sine x, the derivative of cosine function is minus sine x, then we have here cos x, and see, we have to find the derivative of cos of sine x. So again we'll adopt the same method here. So the derivative of cos sine x is minus sine of sine x, and then by chain rule the derivative of sine x is cosine x, right? Okay, so now here we have this result, right? So we can simplify it. So this is minus sine x, and we have cos of sine x, and then here we have minus cos x, and cos x is cos square x, and here we have sine of sine x, right? Okay, so now see, we have to reach this statement, right? So what we will do, see here we have cos of sine x, right? And cos of sine x can be obtained from this equation, right? See here we have cos of sine x. So from here we can write cos of sine x is equal to, we can take cos x to the denominator here. So we have 1 over cos x and dy over dx, right? So now we have here minus sine x, and here we have this term for cos of sine x. So we have 1 over cos x and dy over dx, and then here we have cos square x, and for sine x we have y, right? So sine of sine x can be replaced by y, right? So now we have this expression. Now we can take all these terms to this side. So now we have d2y over dx2 plus sine x over cos x. This is sine x over cos x, then dy over dx, and then we can take this term also to this side. So we have plus y times cos square x equal to 0, right? And sine x over cos x can be replaced by tan x, right? So we have d2y over dx2 plus tan x, and here we have dy over dx plus y times cos square x is equal to 0, right? So this is the desired result, right? So this is how we can solve this problem. Now let us take the second one. So here we have the second problem. So if y is equal to sine of log x, then we have to show that x square d2y over dx2 plus x dy over dx plus y is equal to 0, right? So here again what we will do, we'll first find the derivative, that is dy over dx, right? So this is the d by dx of sine log of x, right? And here again we'll make use of the chain rule, and the chain rule says that first we'll find the derivative of sine log x with respect to log x, right? So we can also write this as d by d of log x here, and sine of log x, and then by chain rule we have to differentiate the log function with respect to x, right? So now the derivative of sine log x with respect to log x is simply cos of log x, and the derivative of log x is 1 over x, right? So this is the first derivative, right? So now what we have to do, we have to find the second derivative, right? So for second derivative we can directly differentiate both sides with respect to x. Then see here we have d2y over dx2, which is d by dx of dy over dx, and this can be written as d by dx of cos log x over x, right? And see, to find the derivative of this function we have to make use of the quotient law, right? The quotient law goes like this: if we have the quotient of two functions of x, that is f over g, then this is g times the derivative of f, then f times derivative of g with respect to x divided by g square, right? And provided g is not equal to 0, right? So but here we'll avoid this method, right? So what we will do, directly from this result we can take this x to this side, right? So if we multiply dy over dx by x, see what we get. We'll get x times dy over dx is equal to cos of log x, right? And now we'll take the derivative of both sides, right? So here we'll skip this method, rather we'll take this x to this side, and then we'll take the derivative of both sides. Now see what we will get. So d by dx of x dy over dx, and see here we have d by dx of cos of log x, right? So we'll again get the same thing which we have done in case of first derivative, right? So here we have now two functions. This is the first one, this is the second one, right? So x is the first function, dy over dx is the second one. So we'll use the product rule, right? So first function is x, then derivative of second function, which is dy over dx, and then the second function, which is dy over dx, and then we have the derivative of x, right? And here the derivative of cos log x with respect to log x is negative of sine log of x, and then the derivative of log x by chain rule, that is 1 over x, right? So now here we can write x, then d by dx of dy over dx is d2y over dx2, and here the derivative of x with respect to x is 1, so here we are left with only dy over dx, and here we have minus sine log x over x, right? Okay, now see, in the given function we are given y is equal to sine of log x, so sine of log x can be replaced here by y, right? So what we will get, x d2y over dx2 plus dy over dx, and here we have minus y over x, right? Okay, now we'll take the entire expression, will multiply by x. So what we will get, so here we'll get x square, and then we have d2y over dx2, and here we have x dy over dx, and here x get cancelled, so we are left with minus y, and now if we take minus y to this side, we'll get x square d2y over dx2 plus x dy over dx plus y is equal to 0, right? Taking this negative y to the left hand side, right? And see, this is the desired result, right? So this is how we can solve this problem. Now let us take the third one. So the third problem is if y is equal to e raised to 10x, right? So here e is the exponential number. So we are given y is equal to e raised to 10x. We have to show that cos square x d2y over dx2 minus 1 plus sine 2x dy over dx is equal to 0, right? So again we'll first find out the first derivative, that is dy over dx, right? So dy over dx is d by dx of e raised to 10x, and here again we have to make use of chain rule, right? So we know that the derivative of e raised to x is e raised to x, right? So here we have e raised to 10x, so the derivative of e raised to 10x is e raised to 10x by using this result, and then by chain rule we have the derivative of 10x here, right? Okay, and we know the direct result for 10x, that is the derivative of 10x is secant square x, right? So this is the first derivative. Now we'll find out the second derivative. So now here what we will do, see we can find out the second derivative by directly differentiating both sides with respect to x. But in that case what we have to do, we have to use the product rule, because this is the first derivative, this is the first function, and this is the second function, right? So here we'll not use the product rule here, what we will do, see, we can express this equation 1 as e raised to 10x is it can be replaced by y, right? So here we can directly replace this term by y, and see, we know that secant of x is equal to 1 over cos x. So we'll write 1 over cos square x, right? And then we can take this cos square x to this side, right? So what we will get, we'll get cos square x dy over dx, and that is equal to y, right? So we can get this equation number 2 by taking e raised to 10x as y and secant square x as 1 over cos square x. Now we can differentiate this equation both sides with respect to x, right? So what we will get, we'll get d by dx of cos square x, and here we have dy over dx, and then here we have dy over dx, right? And see, here we have the product of two functions, so we can take this function as f, this function as g, and we can use the product rule. So the first function is cos square x, then the derivative of g, which is dy over dx, and then we have here dy over dx, that is the second function, and the derivative of cos square x, right? And here we have dy over dx, right? So now we can write here cos square x, and d by dx of dy over dx is simply the second derivative, and here we have dy over dx, and see, we have to find the derivative of cos square x, and here again we have to make use of chain rule, right? So what we will do, here we'll first apply this rule, that is x raised to n. The derivative of x raised to n is nx n minus 1, right? So here we can take cos square x, so this is 2 times cos of x, because 2 minus 1 is 1, so we have simply 2 cos x, and then the derivative of cosine x is minus sine x, right, by chain rule, and here we have dy over dx, right? So now we can write cos square x, this is d2y over dx2, and see, here we have 2 cos x sine x, right? 2 cos x sine x, and from trigonometry we know that 2 cos x sine x is simply sine 2x. So here we have negative of this negative sign, we can take it here, and we have sine of 2x and dy over dx, and here we have this dy over dx, right? Okay, now we can take this dy over dx to the left hand side, so we can write cos square x d2y over dx2 and minus sine 2x dy over dx, and minus dy over dx is equal to 0, right? And now if we take dy over dx common from these two terms, what we will get, we'll have cos square x d2y over dx2 minus we'll have sine 2x, then plus 1, and here we have dy over dx is equal to 0, right? And this is the desired result which we have to prove, right? So this is how we can solve this problem. Now let us take the fourth problem. So here we are given the function, that is y is equal to cot inverse x square. This is the whole square here, cot inverse x whole square. Then we have to show that x square plus 1 whole square d2y over dx2 plus 2x x square plus 1 dy over dx minus 2 is equal to 0, right? So let us start, and let us first find the derivative, that is dy over dx. right? So here we have will differentiate both sides with respect to x. So we have d by dx of cot inverse x whole square, right? Okay, now here we'll make use of one standard result from differentiation. We know that the derivative of tan inverse x is 1 over 1 plus x square, but the derivative of cot inverse x is negative of 1 over 1 plus x square, right? And here since we have to find the derivative of a function, because here we are the power function is also involved, so we'll make use of the chain rule. So we'll also make use of this result, that is the derivative of x raised to n is nx n minus 1, right? So here first we'll differentiate cot inverse x whole square with respect to cot inverse x, right? So we can also write it like this. Here we can write cot inverse x, and then here we have cot inverse x whole square, and then by chain rule we have to differentiate cot inverse x with respect to x, right? So in this lecture we have seen that the chain rule is a very important tool in differentiation, right? So now the derivative of cot inverse x whole square is simply 2 cot inverse x by virtue of this result, and here the derivative of cot inverse x is minus 1 over 1 plus x square, right? So this is the first derivative of y with respect to x. Now this is equation number 1, and now we can differentiate both sides with respect to x to get the second derivative, that is d2y over dx2, right? But here we have to use the quotient rule, right? Because see this is minus 2 cot inverse x over 1 plus x square. So this is the first function, this is the second function, and to get the second order derivative we have to make use of the quotient rule, right? But here will not use the quotient rule, right? So what we will do, we'll take 1 plus x square to this side, right? So we have now 1 plus x square, here we have dy over dx, and here we have minus 2 cot inverse x, right? So now we can differentiate both sides with respect to x, right? So here we have to make use of the product rule. So now we can write dy dx of 1 plus x square, and here we have dy over dx, and here we have the derivative of minus 2 cot inverse x, right? So now we can take this as the first function, that is f, this as the second function. So the first function, that is 1 plus x square, and the derivative of second function, which is dy over dx, right? And then we'll take the second one, so this is dy over dx, the second function, and then we find the derivative of 1 plus x square, which is the first function, right? Okay, so here we have minus 2, we can take negative 2 outside because this is a constant, and we have d by dx of cot inverse of x, right? Okay, so now here we have 1 plus x square, and this is the d2y over dx2. Always remember that d by dx of dy over dx is equal to the second derivative of y with respect to x, right? And here we have dy over dx, this dy over dx, and here the derivative of 1 is 0 being a constant, and x square, the derivative of x square can be obtained from this result, that is simply 2x, right? And here we have minus 2, and the derivative of cot inverse x by this rule is minus 1 over 1 plus x square, right? So now we can simplify this equation. Now see here, minus 2 multiplied minus 1 is plus 1, and now we can throughout multiply this equation by 1 plus x square to get rid of this 1 plus x square, right? So what we will get, will multiply this entire equation by 1 plus x square, right? So here 1 plus x square times 1 plus x square is 1 plus x square whole square, which is this term, and then we have the second derivative, and then we have 1 plus x square times 2x is 2x times 1 plus x square, and then we have here the first derivative, which is this term, and here 1 plus x square and 1 plus x square get cancelled. Minus 2 times minus 1 is plus 2, right? And now we can take this 2 to the left hand side. So we have 1 plus x square d2y over dx2 plus 2x 1 plus x square. Then we have dy over dx, and minus 2 is equal to 0. So taking this 2 to this side, so we have minus 2, right? And this is the desired result, right? So viewers, in this lecture we have solved 4 very important conceptual problem from differentiation involving second order derivatives, right? So this is how we can solve these problems.